So here we go, round two.
Just like that.
Yes. Okay. So what we're doing in this, part of the lesson, we're going to do the opposite we did before. So we're going to start with a graph. We're going to make equations that are going to actually use, them for things. Example 1. Make an equation using cosine for the following. Okay, so we're going to draw a rough little sketch right here. Okay, so this is just a rough little sketch here. Again, if you're doing this in your books, it doesn't have to be with great detail for this. I'm more interested right now in making the equation. Okay. So again, we're just working backwards from what we did before. So here's my beautiful graph. Other ways you guys can all see it. There's my graph like that. Okay, get out of the way and try that. So if you're looking for what the points are, there's a point at 0 and 3, 45 and 5, 90 and 3, 1 and 135, 180 and 3, 225 and 5, 270 and 3, 315 and 1, and 360 and 3. Okay, so in this case, it's just a general equation, but we'll get to examples that actually involve real-life scenarios here, and that's the idea. We're going to make an equation for this right now. All right, so going back to the beginning of the unit, we learned that our standard equation was in this form. Okay, that was our standard equation right from the beginning of this unit here. I'm going to start with Desiree right now. Desiree, do you remember any of the, what do you need for an equation? When I got you to graph something, what were the 4 things that we needed? When I throw an equation on the board, what do we have to graph? Axis is good. So which one of these letters is going to be the axis? No? Somebody help me right here. Yeah, D, because you're adding up here, right? So D is going to be your axis here. Okay. I'm good. All right, Cassie, what else do we know here? What else do we use that equation for? Any other part? Yeah, the period is going to be what? Very good. Excellent. Okay, that's very, very important. Haley, anything else that we know? Any of those rest of those letters? Oh, it's okay, sorry. Luke, what else do we know?
A is something.
A is something. Good. Can somebody go into a little bit more detail? A is not going to be phase shift. If I say 3 coasts, what's 3 coasts mean? Amplitude. A is going to be your amplitude. Okay. And B is going to be your phase shift. Okay, so what we're going to do here is we're going to take our graph here and we're going to try and get those 4 pieces of information from our graph. Okay, and work backwards then and make the equation. Yeah, Alex, go ahead. The axis is going to be 3, and I'm going to show you exactly how we get that if you can't look. In this case, it's obvious because I drew a nice little simple graph that that's your axis. But the equation for axis is going to be max plus min over 2. Okay, and just to use that, the highest point was 5. The lowest point is 1 to divide by 2. Again, if you can see it, that's fine. If you can see it, that's fine. If you can't calculate, that's the calculation. Okay, can someone else tell me something else you know from that graph? What would the amplitude in this case be? If the axis is going to be 3, what's the amplitude going to be? What is it? 2, okay. My amplitude is 2, and again, it's just going to be this distance again. That's your amplitude. If you need to calculate it, this is going to be max minus min over 2, which happens to be 5 minus 1 over 2, which is 4 over 2, which is 2.
On our test, what we have.
No. What will happen on your test, though, the question will be something like, Mr. Sadler's patience, you know, then his minimum patience in class is 48, his maximum patience is 102. It's not real obvious what the axis of that's going to be, right? So if there's like, this is a nice simple first example that has numbers that you can see, okay, right? But there's not. Okay, here's the hard part. The last two parts are difficult. I have to get what the period's going to be. And this is the difficult part of this. Can someone take a guess what the period's going to be in this case? And we'll talk to it at the end. What's the period going to be here? That's 3 people, that's it. Georgia, go ahead. How'd you get 180? Yeah, so what the period's going to be, remember, it's going to be your distance from your max to your max. So in this case, it's from 45 to 225, which happens to equal 180 degrees. Okay. So please ask if there's a question of that, because the period is the most tricky part of this. Okay, we're good? Yeah. All right, our last part's going to be the shift. All right. So for the shift, okay, this is another thing that's a little tricky, so I'm going to try and do it some red here. What the shift is going to be, it's going to be from 0 degrees to your first maximum. Okay, because remember, cosine is going to start at, cosine is going to start at the maximum. Okay, so it's going from 0 degrees to that. So in this case, what's my shift going to be? Aaron, is that structure a question? Yeah, go ahead. Well, because I'm going to do that for the next example. So the thing is, I'd say something like Spider-Man jumps off of, you know, the top of an 18-meter building, right? After 3 seconds, it is his highest point. I'll give you like some sort of wording like that, so it's obvious what it's going to be. But yeah, if you're not giving a graph. Go ahead. Very good. So I'm going to say 45 degrees right. Okay, are we feeling sort of okay with the first one? I know first time through it's a little tricky. We'll make the equation here in a sec. Georgia, go ahead. Yes. Now I'm going to recommend you always use cosine though, because it's very, very easy to have a point. It's possible for a graph that you don't have a point right on the axis. If you have a point on the axis, then yes, you can use sine and have no shift. But I'm always going to use cosine, because if you're dealing with real life, again, you're dealing with something that moves like this, you will necessarily have a point at the minimum, at the axis, maybe. You will have a point, but will it be something you can usually measure? No. It's very easy to find the highest point, right? And that's very easy to do, so use cosine. Okay, so let's try and get an equation here now. I'm going to start with y equals. Okay, let's let a brave soul try and get me started here. What's the a in this case? All right, 2 is this. Cos. Okay, here's the difficult part. What's my k going to be? Sorry? 2, very good. How'd you get that? Very good. So we're going to say 360 divided by k equals 180, which happens to be your period. So k is equal to 360 over 180, which equals 2. Excellent. Very, very good. Okay, I put my theta in there. What's the shift then? Theta minus 45 degrees. And then plus 3. Okay. Shelby, how you feeling? Okay. Okay, how are we doing for time? We got lots of time. So I'm going to throw one more graph. I want you guys to try this yourselves and give a good attempt at this. Once you get these down, life is really easy. So this is the equation, though. This is going to be. So what will happen is we'll turn this into a word problem, starting with the next example. I'll say, using this equation, when is Cody's height 4 meters? When you store. Here we go, example 2. It's going to say, model this graph with the cosine equation. Okay, so I'd like you guys to give an attempt at this one, please. The points are, I'll actually draw the coordinates on here if you need them. The points are going to be, this is 20 and 180, 60 and 370, 100 and 180, and then 140 and 370. Okay, so this is one that when you guys are saying, well, yeah, you can just see the max and the axis and all that stuff. It's a little bit trickier. You may have to do a calculation here. If you can eyeball it, that's fine. Okay, George is trying to eyeball it right now. If you can, 60 is supposed to be 370. That's how it's supposed to go. Okay, but again, this is one that's not real obvious what the axis, the amplitude, and all that stuff is going to be. So you might do a calculation. I'm going to hit pause. I'll give you guys a chance to do it, and the magic of the internet will show. Whoops, you don't need to see my classes. And the magic of the internet will show